Okay, let's continue. So we've just seen how you can create parameterized queries. But there are a few more things to explain about what's happening in that demo. The first question is a really, really important question. Because if I'm saying, oh, this is going to be a great solution for filtering data before it goes into Power Pivot, the big question is, well, where does that filtering actually take place? Because if I have got a billion row table sitting in SQL Server, I do not want to have to download all 1 billion rows onto the desktop and do the filtering there, because obviously that's not going to work either. So this brings us on to the topic of query folding. So query folding is the technical name for the way that Power Query, where possible, will try to push the logic of a query back to the data source. Now, for certain types of data source, like relational databases, like SQL Server, Power Query will look at all of the steps in your query, and it will try to translate everything back to SQL. So it doesn't do the filtering work itself, it will push everything back to SQL, because obviously that is going to be much, much faster. Now, this cannot happen for all data sources. Obviously, you can't push a filter back to a text file because there's nothing there to do the filtering. But like I said, some data sources like relational databases do this. The other major group of data sources is OData data sources. Has anybody come across OData? It's quite an interesting thing. It's Microsoft's kind of standard interface for web services that return data. But OData data sources have got this kind of concept of a query language almost built into the URL, and Power Query understands that. Even things like Exchange, I believe, have the ability to do some filtering on the server. So it will depend on the data source. It will also depend on what you're doing in Power Query. Because there are some things that you can do in Power Query that Power Query will never be able to translate back to SQL. Certain types of complex calculations, it's just going to say, well, I just can't do that. There are also going to be some things that you can do in Power Query that could potentially be translated to SQL, but the Power Query team haven't got round to doing it yet. These things are changing all of the time. So when I first did this demo about 6 months ago, I had a really nice scenario of some kind of transformation step in the middle of the query that would stop query folding happening. But now the demo doesn't work because the Power Query team have managed to fix that scenario. So they're doing a lot of work to enable Power Query to be able to fold data transformations back to SQL. And it's getting much, much better as a result. And obviously this can make a big difference to performance. The bad news about query folding is that there is no way in the user interface for you to know when it's happening and when it isn't happening. All you can do is look and think, this is using a lot of memory, or wow, this is slow. For something like SQL Server, obviously, we can look inside Profiler, and that's what we're going to look at in a moment. Also, what you'll find is that a query might be partially folded. So even though there are some things that Power Query knows how to translate back to SQL, there are other things that it can't. It might move some of those transformations back to the SQL. And you might also find that reordering some steps also allows more things to be folded back to SQL. Because it could be that the order of the steps is actually irrelevant for the final output, but if you do the things first that can be translated back to SQL, and then after all of that you do all the difficult stuff, you might well end up getting better performance. But really it's just trial and error. There are no rules to follow. There are no tools inside Power Query to work out how this is done. Now, in the example we were looking at here, we're taking a table and we want to filter by a day name. So we can all imagine what the SQL is going to look like, and I'm going to show you the SQL in a minute. But this brings up a whole other question. And this is the question of data privacy. Now, Power Query cares about data privacy. It cares more about data privacy than you and I do, but actually, you know, in this day and age, we should all care about data privacy because we could get into a lot of trouble in our jobs as data professionals. And Power Query is going to help us. Think about that demo that I did before the break. Think about the SQL that would have been executed for that. It would have a where clause in, where day name equals Sunday, day name equals Monday. What's happening there? What's happening is that we are taking some data from one data source, the current Excel worksheet, and we're sending it somewhere else. We're sending it off to SQL Server. And a DBA looking at that query will be able to see data coming from our worksheet. Now, we don't care about day names, but what happens if we were sending credit card numbers or something off to SQL Server? What happens if we were accessing a web service? What happens if we were getting customer addresses and we were saying, oh, wow, look, you know, Power BI, I've got a list of customer addresses. Let's see them on a map. You know, Power BI makes it really easy to take customer addresses and geocode them, turn them into latitudes and longitudes and put them on a map. That would be really cool to do. But actually, hold on, what's happening? You're taking customer addresses and you're sending them over the internet to some web service. And those customer addresses will probably be held in a log somewhere so that some guy at Microsoft or the FBI or the NSA is going to be able to see all of these customer addresses. This is possibly a problem. This is something we might lose our jobs about, so we need to care about it. Okay. Here, back in my original demo, in the Power Query tab in the ribbon, I can go to data source settings. And Power Query here stores a list of all of the data sources that I have ever used on this machine. And here, independent of the workbook, Power Query can store information about the privacy levels for each data source. Now, here is the workbook that I'm working with at the moment. Now, when I was doing that original demo, I clicked through some stuff very, very quickly. But what I was doing was I was specifying the privacy level for the data in this workbook. And there are a couple of privacy levels that I can set. So none just means we haven't set one yet. But we can also say that this data is public, organizational, or private. Now, as soon as Power Query detects that data from one data source could be sent off to another data source, then it will prompt you to set a privacy level for that data source. So as soon as I was building that last demo, as soon as Power Query said, data from the worksheet is going off to SQL Server, it prompted me with one of those yellow warning boxes to say, you need to set a privacy level for this. Now, I set it to public. Public just means that data can go anywhere. I don't care about where this data goes. So data from public data sources can can be sent anywhere. Data from organizational data sources can only be sent to other organizational data sources. So you could think, if my worksheet was inside my company and the SQL server that I'm accessing is inside the company, then these are both organizational data sources, and actually it doesn't really matter if I'm sending data from one organizational data source to another, because it's all staying inside my company. It should all still be secure. Yeah. How does it know? It's just anything. Well, it doesn't know. It's just that you've said that the both data sources are organizational. So it's up to you. And then finally, private data sources. Any data source marked as private cannot have its data sent anywhere else. Now, there are two things that can happen when you set a privacy level. If we think about the example we've got here, if I set the privacy level to private, I would be saying that data from this workbook cannot be sent off to SQL Server. The query would still work, but what Power Query would do would say, well, I can't send the data off to SQL Server, so I'm going to have to download the entire table and do the filtering on the desktop. So the query would still work, but it would possibly be a lot slower. The other thing that could happen would be that the query would break completely. So let's imagine we're taking those customer addresses and we're sending them over the internet to a web service. If I said my customer addresses were private, then we couldn't send them over the internet. We couldn't do the geocoding, and Power Query would just say, sorry, we can't do that at all. The query would just not run. So this can end up being a little bit of a nag. It's a bit of a pain. You've got to set the data source privacy levels. It gets in the way a little bit, but actually this is something we should take seriously, because potentially we and our companies could get into a lot of trouble doing this. The other thing to say about this is that if you do get a little bit bored of having to set the data sources, you can go to Options, Privacy, and you can choose this option here to ignore all privacy levels. And this will just simply say, oh, screw it, let's treat everything as public. This is the nuclear option. I use it myself all the time, but it's probably something we shouldn't be using in a real production environment. But anyway, I've set my data source levels to public, and what we will see is if we change this to Thursday, I have SQL Server Profiler running here. We can refresh our query, and at some point in amongst all the SQL that's going to be generated by Power Query, what we will find fairly soon is the actual query executing. There we go. And there is, whoops, there's the query that we wanted. And you can see that everything we did in that query has been folded back to SQL Server. It's just getting the columns that we want. It's even done the aliasing in there. And here we've got English day name of week equals Thursday. So in this case, we've been lucky. Everything has been folded back to SQL. So we would expect fairly good performance for this. Clearly something else is going wrong in SQL Server to make it slow, but you saw in the other more advanced demo, weirdly enough, it's fast. All right. That's enough about privacy levels. The last major thing to learn about the M language that you will need is the ability to write your own functions in M. So M has a whole bunch of built-in functions. We've seen them already. These are the functions for splitting columns, filtering tables, aggregating, all kinds of other things. And in M, you also have the ability to define your own functions. You have to define them in M, but then once you've defined a function, you can then use these functions elsewhere. So let's see an example of this. So I'm going to create a new blank query. And here, I'm going to write an expression that returns a function. A really simple function. And what we've got here is a function that takes two parameters. I haven't even bothered setting data types. The two parameters are x and y, and it will return x multiplied by y. So I've defined a function here. This expression returns a value of type function. So I'm effectively declaring a function here. I'm going to call the query multiply numbers. And you can see here that Power Query has realized that this returns a value of type function. And now I can go back to my daily forecast and I can say, well, let's add a custom column. And here, let's call my function and get the value from the temperature column and multiply it by 2. So I can, having declared my function, I can now use it in other queries. In this case, it's just going to give me temperature multiplied by 2. So very straightforward. So obviously, functions are useful for sharing common calculations around multiple queries. And you know, there are going to be lots of situations where you have maybe a shared bit of code that appears in lots of queries. You put it into a function. You can call that function from all of your queries. It's going to be really good from a maintenance point of view. But there are other uses for functions as well. So we can use functions to control data access. So taking the scenario we were looking at just now, we want to be able to load data from our big table somewhere in SQL Server. We could use the parameterized data access approach that I showed you earlier. We could also use functions instead. So the parameterized data access scenario allowed us to have one query that could return different results. Instead of doing that, we could create a function, and a function will allow us to create multiple queries that return multiple slices of data. And that might be useful in a slightly different scenario. So let's see how to do that. There is my parameterized query. Let's grab all the code here. Let's now create a new blank query. Let's call this get days. I'm going to edit this and paste the code in. Now what I'm going to do is I'm going to turn this into a function. And to do that, all I've got to do is, before the let expression, say that. So all I've done is added this first line at the top that says, let's make all this into a function. There's one parameter, it's a bit of text, it's called day name. So this is where the end user is going to type in the name of the day they want to filter by. And here, instead of referencing the output of the data filter query, I'm now going to reference the value passed in that parameter. So that value passed in is going to be the value that I filter by. So I've now got another function, another query that returns a function. Let's, for some reason that always likes to update. Come on. All right. Now I've got this function, I can invoke it. So I can either double click on it or I can right click, invoke. And when I do that, I get prompted to enter the parameter. So I can enter Sunday here, click OK. And what's happened is that it has created a new function. It's given it an ugly name, but I can rename that. Let's call this Sundays. Close and load. Load that to a table. And there are all of my Sundays. So the difference between this and the parameterized query approach is the parameterized query approach just has one query that can return multiple different values. What I'm doing here with a function is I'm saying, well, okay, here is a function that I can then invoke multiple times to create multiple queries, and then I can pass in different parameters, and each query then will just call that function and get a different parameter, and get a different slice of data. And I could go away and create multiple queries here that all reference the same function. And if we look at the query that's been generated for us, that's all the code. The code just simply says, call that function with the value you typed in. So you can see this is going to be useful for slightly different scenarios, where people want to be able to create multiple queries that are all effectively doing the same thing with a different slice of data. The box that appears up here can, to a certain extent, be customized. So you can put in prompts, you can put in default values, you can even have a drop-down box containing a list of values to choose from. Unfortunately, the code to do this is really, really horrible. I don't know why they haven't made it a bit easier, but it is possible, and I've got some examples on my blog of how to do that. But it's not something that is as easy as it should be. That's not the only use for functions. Probably the best use for functions, or at least the most common practical use for functions, is the ability to combine data from multiple instances of the same data source. Now, does anybody have any friends that are heavy Excel users? Yeah? You know, those friends in accounts or something. Do you want to really impress them? Yes. All right. This is the demo for you. Because whenever you show this to Excel users, they just go wild with excitement. Power Query has built in the ability to merge data from multiple CSV files. So this is something it can do out of the box. So I'm going to do this demo first. What I've got here in a folder is a bunch of CSV files. The CSV files have all got the same structure. So if we look at January sales, they've got January sales for apples, oranges, and pears. February sales, March sales. So maybe every month somebody sends me a CSV file with all of this data in. Or maybe I'm not allowed to download all the data I need from some website, and maybe I've got to download it in multiple different pieces. Now, these are CSV files. Power Query can handle these really nicely. So this is one of the standard crowd-pleasing demos for Power Query. I can take this folder, I can go to the Power Query tab, from File, from Folder. I can point it at this folder. Now, when I point Power Query at this folder, it will treat the Windows file system as a data source, and I get a table with one row for each file in this folder, and I can see all of these other columns, attributes, date modified, extension, and so on. So I could, load that table into Excel, but because I know these are CSV files that have the same format, on top of the binary values here, I have this special button, and this button allows me to take all of the data from those CSV files and combine it together. So when I press this magic button, I get one table containing all of the data from all of the CSV files inside that folder. And now if I drop another CSV file in that folder, that will also automatically get merged in. It's just simply saying connect to every CSV file in that folder, merge it all in, create one result set. So you do this at your user group, or you do this to your colleagues, and they'll say, wow, that's really amazing, that's really useful. And then that Excel guy will say, oh yeah, that's great, can you do it with Excel? And unfortunately, the Power Query user interface doesn't do this with Excel files. Because with a CSV file, well, there's just data in a CSV file. With Excel, you can imagine it's a little bit more complicated. Do you want to get the data from sheet 1, or from a named range, or from a table, or from lots and lots of different places? But now that we know a little bit about M, and now we know about functions, I will show you the technique that will allow you to merge data from multiple Excel files, or indeed from multiple instances of similarly structured data sources. You can imagine that if you've got 5 instances of SQL Server with the same table, you could use the same approach as the one I'm going to show you. Let me walk through. Rather than looking at CSV files, I have a folder here with 3 Excel workbooks in. There's some other junk in here just to prove that we can ignore some of the other junk. But we've got 3 Excel files which have all got the same structure in. Again, one has got sales for January, one has got sales for February, and one has got sales for March. If we open up this first workbook, you can see that on sheet 1, we've just got some values put on sheet 1. This is probably the most common way that you'll get data in Excel. On sheet 2, I have data formatted as a table. On sheet 3, I've got data in a named range. We can handle all of these. But anyway, this is going to be our template. We're going to assume that the other workbooks, even if they have different data, are structured in the same way. So the first thing we do in Power Query is we're going to connect to one workbook. So let's connect to this folder. And let's connect to Sales Book 1. And let's get the data from sales table. That just happens to be the table of data that was on the second sheet. So we want to get the data from the sales table in every single workbook. I'm going to edit this. So there's our query that would get the sales data from Sales Book 1. The next thing we need to do is take this query and turn it into a function. If we have a look in the advanced editor, the code is very easy to understand. The first step simply connects to the Excel workbook, and there is the name of the Excel workbook we want to get data from. So let's turn this query into a function, and let's pass the file name in as a parameter. You have to be careful in M, it's case sensitive. So there's my parameter file name. So all I've done is added this first line at the top, declared, turned this into a function, declared a parameter called file name. And then here, instead of getting the data from sales book 1, I'm just going to add the file name variable or the parameter value onto the end of the folder name. So there's my function. It's going to be called sales table. All right. The next thing we need is another query. And we're going to go back to that folder here. I've used the from folder query type again. So in my second query, I'm now connecting to that folder that I showed you earlier. Now, like I said, there's some other junk in here. So maybe I want to filter things down. So maybe I only want the files with the XLSX extension on. So that gives us just the 3 files that we want. Now remember, if I was to click this button, it's there, it's tempting, it's not going to work. But there is a column with all of those file names in. Let's remove everything else. Now what I can do is I can add a column, add a custom column, and here, for each row, I can create a calculated value. And what I'm going to do is I'm going to call my function with the file name on the current row and return the value of the sales table in each workbook. So if I say sales table name, I'm calling my new function sales table, and for each row in this table, I'm going to call the function and get a table of values back. Click OK. That's worked. Now, a table, like I told you, is just a data type like any other. And in Power Query, inside a table, inside a cell, you can have any data type, which means that you can have tables inside tables. And that's what we've got here. We've got in each of these 3 cells a value which is of type table. And as soon as you have that, another magic button appears at the top, which is the expand button. And that simply says, well, let's expand this table and see all of the values in those nested tables. So all I've got to do is click this button. I want to use the original column names, and bingo. We have all of the data from all of the sales tables in all of those Excel worksheets inside a single table. Another question that people have been asking me all week for user groups is they've been saying, well, you know, Power Query is really good, but are you doing any consultancy with it? I am, not a vast amount, but I am doing consultancy. And in every single one of those consultancy jobs, I have used this trick, either on Excel workbooks or some other data source. This is a really, really useful pattern. And this will save somebody absolutely days of work. Alternatively, it'll put somebody out of a job, because there are some cases where people's entire job is doing this kind of data munging. But there we go. We can take that data and we can load it to a table. So there's all our combined data. Yes?
Does it work well on XML data if you combine multiple files in a folder?
Yep. Power Query can handle XML and JSON. When you see an XML file, XML is it comes in as a kind of nested data source as well, but there are lots of options for kind of either navigating through the XML to find the data you need, or indeed using the expand button to collapse an XML file into a tabular structure. So but the basic approach is always the same. Connect to one file, build a query to get the data that you want, turn that into a function, then connect to your folder containing all of the files, call the function for each one of the files, and then click the expand button again to merge everything together. The last thing that I'm going to show is working with web services. Another really common thing that people want to be able to do in Excel is call web services. Excel doesn't make it easy to do this. You can do it in VBA. It's a bit of a faff. There is an Excel worksheet function called web service, but it really doesn't work very well. Power Query, I think, is the easiest way to call a web service from Excel. Now, we can see some really complicated examples of this in code, but I can direct you to my blog. But what I want to do as my kind of last two demos is show you two more fun things. Right, now, do we all have our devices with us? Yes? All right. Have we all done our email? Good. All right, so if we've got internet access, I want you to go to the following URL. This isn't your survey, this is my survey. Now, just to prove that it's all right, I will, before you copy this down, I'm going to show you what this URL gives you. So this URL will take you to an Excel survey. And all I want you to do with this survey is to write a comment in English about something to do with Power Query. It doesn't have to be what you actually think of Power Query. In fact, by all means say something rude. Don't say something really rude, but because it's going to be shown on screen. But say something, a short sentence, and then make sure it's in English. And what we're going to do with this is that we're going to perform sentiment analysis. We're going to see whether your phrases are positive or negative or not. So all you've got to do is type something in English in there, and that is the URL. The URL is case sensitive, so you will need to type the correct case. So I'll give you a few moments to do that. And while you're doing that, I will explain how I'm going to do the sentiment analysis. I'm going to call a web service. The easiest way to call this particular web service, this is an Azure machine learning web service. Azure Machine Learning does actually expose, does actually give you the ability to expose web services once you've put them into production. You can also get hold of the sentiment analysis API a sentiment analysis API built in Azure Machine Learning through the Azure Data Market. So the Azure Data Market is a site that Microsoft provides for selling access to APIs and data sets and so on. So if we all manage to connect. So this is the Azure Marketplace. If we click on Data Services, what we can see here is a list of data sets and services that I've subscribed to. A lot of these are free. And what I'm going to be using is this lexicons-based sentiment analysis API built with Azure Machine Learning. Now, it's free, but only up to 26,000 calls a month. But I think we should be okay. If I click on Explore here, I can even test the API. So I can type a sentence here like, "This is great," and apply, and it will return the result 1, which is very positive. And if I say this is bad and click apply, it will return -1, which is negative. So all it's going to do is we pass it a short sentence. It will say, is this a positive sentiment or a negative sentiment? Well, we will see some examples of that. Now, I've kept all of the data from Gothenburg and Malmö. And some guy in Gothenburg, as you'll see in a minute, was trying to be a little bit clever. But let's have a look at all of the data. So here is my sentiment analysis survey. And if I show you here, this is the smart ass. But anyway, we've got a table of data, and I'm going to open this in Excel. So we're going to open up an Excel file with my table of data in. It's formatted as a table. So that means, of course, I'm going to be able to open it up in Power Query very easily. Now, before I do that, in Power Query, because I've got Professional Plus, I can access all kinds of Azure data sources like the data sets and services that I've subscribed to in the Azure Marketplace. So if I click on this, I can see my subscribed data sets, and there is lexicon-based sentiment analysis, and it can actually see that API exposed as something that Power Query recognizes as a function. Now, if I double-click on that, it thinks that I want to call the function, so I don't want to do that. It will create a query that calls that function, but I don't want to call the function, I want the function itself. So what I'm going to have to do here is do a bit of manual editing. Let's delete the step here that invokes the function, and let's return the function itself. Again, the variable names are a bit complicated, but there we've got our function. So we've got a query that returns a function, a query that will hit that web service, and there we go, it's called score. So we go back to here. There is my table of values. I go to Power Query, from table, and now again I just say, well, let's add a column, we'll add a custom column, call this score, call the score function on the text in this column, click OK. Again, I get prompted for data privacy because this is a new worksheet. I'm sending this stuff over the internet. I want to set this to be public because I don't care about your sentiments. And then it's going to go away. It's going to call that web service for every single one of those rows in the table. Now, this is a fairly inefficient way of doing things. You know, if I had a bit more time, what I'd actually do is bunch all this stuff up together and send it off as a batch. But that takes a little bit more complicated programming. The next example that I've got will show you doing that. But what we will get in a minute, there are too many people here, is we've got our table. Again, we've got a nested value, but we've got records. Remember I said a record is like a table with just one row in it. I can expand and get the result. And there we've got all of our values. You can see that this is marked as something maybe slightly negative, which is quite good. The terrible, wonderful guy, utter bollocks. Wow, that's really good. We've got an error for here, but we've also... I hate to break it to anybody that thinks that. But the terrible, wonderful guy somewhere up here will be coming out as 0. So the terrible obviously cancels out the wonderful. And of course, now I've got this, I can say, well, let's see what the people of Sweden think overall about Power Query. And we can say, let's do a group by. Let's get rid of that. Let's call this average score, average of results. Hold on. What I need to do here was filter out the errors. So let's replace all the errors. This is a good thing that I didn't show. So we can replace errors. We've got some errors because somebody has gone in and entered a number. So if I was to right click and replace errors, let's replace errors with zeros. So this will go in and replace the errors, and then I'll be able to do my group by and average score. And we can see that you're mildly positive, but maybe not completely impressed. This is a very, very simple example of calling a web service. Something a little bit more advanced, but not by any means too advanced, is this one here. No, not that one there. This one here. So most of the time when you're calling a web service, you're not going to the Azure Marketplace. You've got to call the web service yourself. What I've got here is a slightly more complicated example where I am calling the Bing Maps API. So the Bing Maps API contains a number of different web services. And one of the web services we've got is the ability to pass in a latitude and a longitude, and then find the height above sea level for that latitude and longitude. So what I'm doing in this query is I'm starting off with a latitude. I'm generating a list of numbers, which is a list of longitudes, in a straight line. So I'm generating a list of points in a straight line. Then I'm combining them all together in one big chunk of text, and I'm sending it off to the Elevations API. And then I'm getting the result back, and pretty much everything after this is just taking the JSON document that's brought back, drilling down through it, and extracting everything so that we've got a nice looking table of data. But everything after this was just done in the UI. I didn't need to write any custom code for it. When I call the Bing Maps API, I have hard-coded a key in here. This is bad practice, but I've put it in here to make it obvious how I'm calling the API. So I'm just putting key equals Bing Maps key on the end. It is actually possible to get Power Query to store this kind of key in its own secure credentials store, so you're not actually embedding it in the code. But effectively what I'm doing is I'm returning a table of latitudes and longitudes with elevations. I'm loading that. Well, I won't load it now because I've done it before. But rather than put it into a table, we can go to Power Map. And here we can see what we've got. Power Map needs good internet access. So all of you people checking your email, you're slowing my demo down. But when it opens in a few minutes, come on. This worked fine in Gothenburg and Malmo. There we go. All right. Here we go. There's my line of points. I've drawn a line of points across Norway and Sweden, and we can see the elevation of all of those points. So for example, if we go into here, we start off in the middle of the sea, and we go across, we hit a very mountainous bit of Norway there, we go across the sea again, and then we end up in Stockholm, which obviously isn't very far above sea level. But we've got a nice cross-section over Scandinavia showing all of the elevations, which again possibly not very practically useful, but you can call the Bing Maps API to geocode addresses, obviously taking privacy into account. There are tons of APIs out there which we can now use. Probably the only wrinkle with this is authentication. So if you've got an API where, like the Bing Maps API, you're passing in a key, Power Query has got great functionality for working with APIs like that. You can generate GET and POST requests, but that's about it. The biggest problem that I've had is with more advanced types of authentication. Power Query doesn't work with OAuth 2 yet. It will do soon. Somewhere it is working. If you've seen all of the Power BI content packs that allow you to connect to Google Analytics and MailChimp and things like that, all of those content packs are written in M in Power Query. They will need OAuth 2. So the language is there somewhere. Microsoft just haven't released it in the official public version of Power Query yet. So this is going to be possible in the future, but at the moment we're a little bit limited with some of the APIs that we can call. Right, that brings me to the end of my presentation. I've got another survey for you, but this is the user group survey asking for feedback. Thank you for listening. If you've got any questions, by all means, ask them now. Yes, sorry.
Those functions you write, can you store them easily in a shared workbook somehow that you use them across an organization?
Not really. Well, there is a story about this. So Power BI is going through, is onto its kind of second version. Power BI version 1 was a service embedded in Office 365. And in Power BI version 1, you could publish queries and functions up to Office 365 and share queries and functions between multiple workbooks that way. Now, Power BI in Office 365 is dying. It's still there, but it's going to be turned off at Christmas. We're all now meant to be using PowerBI.com. PowerBI.com does not have that functionality. That functionality instead has been transferred to Azure Data Catalog, which is a separate service, which is all to do with controlling metadata. I'm not sure whether it does at the moment, but that will give you that ability to share queries and functions between people in your organization, but you're going to have a subscription to Azure Data Catalog. The reason I haven't played with it is that it also involves setting up Azure Active Directory and all kinds of other tricky things. So it may not be something that you're allowed to do. But that is going to be Microsoft's answer for sharing queries across multiple workbooks. Of course, if you've got Excel 2016, you could, just copy and paste a query from one workbook to another, or use some VBA to export from one place to another. Had another question at the back. Ask nicely, upgrade to Excel 2016, which I know is even less likely. You've got a problem. If people aren't allowed to install Power Query, they can't use Power Query. I know what it's like in a lot of organizations. It's very difficult to get things installed, and people are very suspicious. IT departments tend to be very suspicious of getting add-ins installed. But, beg and plead and, Yes, but then you have to have permission to get Power BI Desktop installed as well.
Could be easier because that's a separate tool. If you ask IT for installing an add-in for Excel, they might go,
Yeah.
no add-ins in Excel.
Yeah, I mean, Power BI Desktop does most of the things that I've shown you. The limitation with Power BI Desktop is that it's not Excel. So Power BI Desktop has nothing where the user can type values in. So that whole parameterized query example, that's not possible in Power BI Desktop yet, because there's nowhere to type values in. And also, another thing that Excel users like is to be able to use Power Query to save it, to import a big chunk of data into the workbook and then save the workbook as CSV and then use it as a way of creating CSV files. You can't do that with Power BI Desktop either. You know, a lot of Excel users want Excel. They don't want Power BI Desktop. But, you know, Power BI Desktop is great for a lot of other things as well. Any more questions? All right, thank you for coming, and hope you go away and have some fun with Power Query. Thank you.